All right, good day everyone. Welcome to HYSYS Academy. All right, HYSYS Academy is a division under HYSYS Limited. HYSYS is going to be providing you with the Aspen HYSYS and Aspen Plus process simulation training. So basically, what we're going to be doing is to get you acquainted with Aspen HYSYS and Aspen Plus. We get you familiar with both softwares and how their interface works. We'll be handling some real world industrial processes, carrying out some optimization processes as well. So it's you'll get more familiar with the software as we go on. Now this training is supposed to go for 2 months, 1 month for Aspen ICs, the second for Aspen Plus, after which you'll be getting your certificate at the end of the day. All right, so what we are going to be looking at now, we're going to be focused on the module one. Now the module one, it has to do with the introduction to process simulation. All right, so process simulation, some of us already have an idea what process simulation is all about, but we are going to be explaining it further. Um, for those that don't really have an idea, we'll actually help you to understand it better. All right, so let's go. So what are you going to be learning from this? The objective of this is to provide an understanding of process simulation fundamentals, the role of Aspen HYSYS and Aspen Plus, and how they are used in industries. We're going to be looking at the overview of process simulation and its application, the differences between Aspen HYSYS and Aspen Plus, understanding flow sheets, unit operation, and thermodynamic models. All right. So, what is process simulation? Process simulation is the use of mathematical models to replicate real-world industrial processes in a virtual environment. It helps engineers and researchers design, analyze, and optimize chemical, physical, and biological processes before implementation. Now, the key things to note with this definition is, first of all, you talk about mathematical models. The next thing you talk about um, real-world industrial processes. Then another key thing to note is the virtual environment. These are the three things to note when it comes to with implementation. Yes, the four things to note actually. So first of all, you talk about the mathematical models. Now, usually before a plant is being designed or a process is designed, usually they carry out a lot of calculations on it, as handwritten calculations and all that. You'll be doing a lot of iterations, doing using different methods, maybe like Gaussian method to solve different things. So basically, you do a lot of calculations to get your process. You understand? To calculate your process to get your product and all. But based on the fact that, and now that is you replicating like a real world industrial process. Now you are bringing this into a virtual environment to do this particular calculation. You understand? That's where you're making use of the software to enable you to be able to carry out this particular um, simulation. You understand? So in the simulation software, they already have the mathematical models at the back end. So it's just left for you to put in some of the parameters, and then you allow that particular unit operation to get solved based on the thermodynamic model you'll be picking for it. You understand? So you'll be selecting some thermodynamic models for these things. So that's why now it's the mathematical model solving the real world process at a virtual end before you now take it finally for implementation. You understand? So that's basically what the process simulation is all about. All right. So what are the key aspects of process simulation? First of all, you predict process behavior. All right. So it helps us understand how a system will perform under different conditions. So you'll be varying different conditions to see how this process is going to behave. Um, to predict, okay, what is the likely outcome of the process. You understand? What's the likely outcome of the process? What you're trying to get, the product you're looking at getting. How are you going to get it when you vary it under different conditions? Now imagine you are changing the temperature, you're changing the pressure, you're talking about the mole flow rate, you are talking about the distillation column, you are dealing with things like distillate to flow, right? Dealing with things like reflux ratio, all those things. So it helps you to have an understanding of how this process is going to behave, trying to predict the behavior of the system. You understand? So the next thing you talk about is the optimization of performance. So optimizing performances. So it reduces the cost, improve efficiency, and enhance safety. You understand? So it reduces the cost. It helps you to improve the efficiency of the process. You understand? So once you have a process running, it helps you to optimize it. Now you can check the performance of the system. If you already have an existing one, you can bring it to the simulation environment, try and tweak one or two things in it, try and understand, okay, how can I be more efficient at the same time producing quality, um, looking at areas where safety could be implemented. Maybe you have to increase safety around the particular unit region due to the heat emitted from that particular region. So these are the things you look out for. You understand? And then it helps you to reduce the cost. All right, so it supports decision making, aids in process design, troubleshooting and scaling up. All right, so when we are talking about the decision making, it's all the same thing. By the time you take your the process into the simulated environment, you run your simulations, you know, okay, this process might not work if I do it this way. If you're having errors, you go to that particular unit, try and understand what exactly is causing the errors in that unit. If the parameters are not conducive for that unit, then you have to tweak one or two things and then make it conducive. So it helps your decision making when you are trying to implement a process, when you're trying to implement a plan. So and then when it comes to the scaling up, once you have your pilot plant ready, when it's time for you to scale up, you can increase the feed and then observe how the product is going to be like. All right. So next thing is it reduces risks and cost, minimizes the need for expensive trial and error experiment. So this actually helps you to cut out the cost of doing a lot of trial and error experiments. Imagine buying your materials to perform the experiment live, and then maybe on the first run it doesn't work or it doesn't give you the expected outcome you want. That particular batch has actually wasted. Yes, you learned from it, but it has actually wasted. So the funds you've actually put into that, it's what's it called, it goes. You understand? Now you have to get another equipment again, or maybe material. You have to get another material again to try and do the process again. So how many times do you want to keep doing this trial and error until you finally get it? This simulation environment now will help you to reduce the cost, because once you carry out your first run, you see that there's a problem, you can change one of the things, change one of the parameters, try and notice where the problem is, do it again, and then if it works, it works. If there's still another issue, you still have to keep um, changing things, to keep working on it to make sure that you get what you are looking for. All right, so now you're not really spending money on getting materials, but instead you are running in a virtual environment, and then it's easy for you without the expense. All right, so what are the applications of process simulation? Process simulation is widely used across industries to improve efficiency, safety, and decision making. Here are some of the key applications. We can use it in the chemical and petrochemical industry. We use it in the oil and gas industry. We have the power generation. We have the pharmaceutical and biotech industry. We have the water and wastewater treatment. We have food and beverage industry. And then we also have the environmental and sustainability studies. All right, so process simulation cuts across so many fields. It's in fact, I would say it's not just chemical engineering orientated, but you can use in the chemical engineering, you can use petrochemical, even mechanicals engineers make use of this too. Understand? So basically it cuts across a lot of fields. And it's not just one process simulation software we have so many process simulation softwares. Understand? So talking about process simulation softwares, it is categorized based on industrial applications, modeling approach, and functionalities. All right. So what are the types of process simulation softwares we have? We have the Aspen HYSYS, we have the Aspen Plus, we have Unisim Design, we have DWSim, we have ChemCAD, we have GPROM, we have ProMax, we have HYSYS Fluent, we have COMSOL Multiphysics, we have Gazprom, and we have AFT Phantom. All right. So the Aspen ICs and Aspen Plus is what we are going to be dealing in this training. That's what we're going to be dealing with. Unisim Design, which is created by Honeywell, is a little bit related to ICs. Now remember, Aspen ICs and Aspen Plus are under Aspen Tech. Now Unisim is under Honeywell. DWSim is an open source software. Then we have the ChemCAD, which is a little bit related to the ICs. Not really related, but in terms of um, functionality. Yes, in terms of functionality, they almost perform the same function. Then you have the GPROM Pro Max. HYSYS and COMSO, they are usually used for CFDs. Then the Gazprom and then FT, EFT Phantom. All right, but our major focus is on Aspen HYSYS and Aspen Plus. All right, so these are the icons for them: the Aspen HYSYS with the H and then the Aspen Plus with the A. All right, so going further, what is Aspen HYSYS? So we've learned about Aspen HYSYS, Aspen HYSYS. What exactly is Aspen HYSYS? So Aspen HYSYS is a process simulation software used primarily in the oil and gas, refining, and natural gas processing. It provides tools for designing, optimizing, and troubleshooting hydrocarbon-based processes. So this is something key to note. Aspen HYSYS is majorly used for hydrocarbon-based processes. Understand? So when you be dealing with oil and gas and the refining processes of it, you make use of Aspen HYSYS. It's more suitable to use Aspen HYSYS for this kind of processes. Understand? Then talking about the natural gas process, maybe you're doing NGL fractionation, you're trying to do acid gas sweetening, all those small things involved, or maybe you're trying to transport the gas from a particular location to another location. So these are the things you tend to use the Aspen HYSYS for. You understand? So anything based on hydrocarbons, it's easier to use your Aspen HYSYS for it. It was made majorly for those kind of industrial processes. All right, so what are the key applications? Let's look at that. We have the oil and gas production and processing. We have refining and petrochemical operations. We have natural gas processing, LNG, NGL recovery. We have pipeline simulation and flow assurance. We have dynamic process modeling and operator training. Okay, so these are the key applications. You can see that everything was related to the hydrocarbon processes. All right, let's go to Aspen Plus. What is Aspen Plus? Aspen Plus is a process modeling tool used in chemical, biochemical, and polymer industry. It is best for reactor modeling, complex chemistry, and thermodynamic analysis. Now, from this definition, we can see that Aspen Plus is broad. Now, it's not just streamlined to hydrocarbons, but it's now broad. You can use it in the pharmaceutical industry, you can use it for your polymer industry, biochemical processes, chemical reactions, complex chemical reactions, and all. So, and even part of the hydrocarbon processes, you can still bring that to Aspen Plus. So, Aspen Plus is broad, it covers a lot. You understand? It covers a lot. It's not streamlined to just like hydrocarbon, but it covers a lot. All right. So, key applications. So, special and specialty chemical production, we have pharmaceutical and biotech process design, we have the polymer production and reaction simulation, we have environmental and water treatment, we have the carbon capture and sustainability analysis. These are the key applications. Now, when do we use Aspen HYSYS and when do we use Aspen Plus? Feel from what we've been saying so far, we should know when to use them. Now, you use Aspen HYSYS if working with hydrocarbons, oil and gas refining, or natural gas. All right, and then you use Aspen Plus in dealing with chemicals, polymer, pharmaceutical, or complex chemical reactions. All right, so with this, we have covered what is process simulation, Aspen HYSYS, the application of process simulation, Aspen HYSYS application, Aspen Plus is application, and then the differences between the two of them. All right, so in the next video, we'll be looking at unit operations, flow sheets, environments, property packages, and then we get to see the interface of the Aspen HYSYS. All right, so remember the first course is about the Aspen HYSYS, while the second is for the Aspen Plus. So we'll be looking more at the Aspen HYSYS interface. All right, so see you in the next video. Thank you.